Hello everyone, welcome to another stream. How's it going? Not sure how long that screen was there for, but yeah, I was getting the baby to sleep. Yeah, didn't go to sleep by himself, which was strange, but that's cool. But yeah, today we're gonna make a start on the editor. Let's get into Helix. Let's build up the game, take a gander. So last stream we got resizing working. So as you can tell, the window's a bit smaller than it was. That's because you can resize it. So we're now, yeah, look at that. Pretty good. I gotta get my laptop on so I can see the chat. Bam. Oh, so it's pretty good. You know, the texture viewer screenshot stuff is a bit broken because of this, but future Henry will solve that. But yeah, we're going to be building in some editor today, at least getting the UI in, some of the groundwork for the editor. Yeah, I'm just going to go with the flow really. But the basic idea with the editor, right, is we want to have a tabbed environment like this texture viewer where we can open up tabs, we get an empty tab, and we can select. We want to make a new asset of some kind, and it opens up that specific editor, right? And also be able to find an asset and actually load it. Right, stuff like that. Just get the groundworks in for that. We probably won't do the loading thing because we don't have anything yet. But yeah. So yeah. I think as well, a safe thing to say is assets won't necessarily be a file on the file system. They could be grouped into a single file. I think I'm gonna do that for materials. Materials are all probably going to be in one single file, I think. So yeah, it's not necessarily a file browser. Cool. So let's get started by going to the editor. So what we have is an editor folder. And it's got a few things in there, like we've got this is where like the core editor stuff will go, stuff that's probably shared amongst all of them. And then we have like a level editor, a model editor, and a material editor. These are the things we want to build within the next 8 months, right? So we're starting off with the material editor, but we need to kind of get the basis or the basics in. So I think we'll get this sort of like tabbed UI, have a way to sort of like create something new, and at least open up a new material editor. And maybe even get the material way to create a new material maybe as well. Cool. So that's the public header. There's also an internal header. Where's my can of Coke gone? Let me go and get my can of Coke. Yeah, I hope everyone's having a good work week so far. It's nearly there, guys. Friday's tomorrow. But yeah. Be right back to get that can of Coke. Right, I'm back with the fuel. Got the Pepsi Max Cherry. Ooh. So yeah, we've already made a kind of editor. It's got like an update function. It's got an initialize function. It's got some spec that you can pass in when you initialize it. And it updates that sort of graphics payload before it sends it to the renderer. And the reason why we did all this was because we added support for gizmos. So we already have like a gizmo thing. You know, I got that in there. That was fun. So you can, I think, press the H key and the gizmo shows up, and you can sort of drag a gizmo thing around. Yes, you can. Look at that screen resize. It's legit. So you can drag this thing around. So this is already part of probably the model editor or something, or level editor as well. This will use this thingy-majig. Yeah, we've got the rotates and the scales as well. So there's that one. But before we quickly start, I want to go into the OS Linux, and actually like that default display dims thing. We divide it by 2. How about we divide by 3 and then times by 2? I don't think the boy's still asleep. Seems like he's playing. I hope he goes to bed soon. Yeah, I think that's more of close to what we had before, resolution-wise. Bit closer. Maybe we could do a divide by 5 times by 3. Would that be more? It wouldn't it? No, it wouldn't. That'd be less. You divide times by 4. 4/5 ish. That's better. That's more like what we had before. So yeah, we can resize this if we want, you know, do whatever we want with it. Now, so that's cool. Look at that. It's like jelly. So I'll copy that line actually, and I'll take that to the Windows one. I meant to make this more platform agnostic, but you know, come from a config file, but I couldn't find a way to pass the dimensions down without doing a little bit of a rework. It wasn't a big one, but I just couldn't be bothered, so I just did that. So in the Windows backend, yeah, because the Windows backend in this backend, it when it opens the window at different points. The Windows one wants you to open the window first before you can do anything, whereas the Linux one wants you to do it at the, or it doesn't, yeah, you can do it at the end. So no, you have to at the end, because you have to initialize the X11 system before you can get the dimensions. So there's probably ways to get the display dimensions without initializing the X11 system, but this was the quick and easiest way to do it. So that's why. But anyway, to the editor. So editor internal. So what I'm thinking we have this sort of tabbed environment where you can click on a tab. Yeah, I think let's just start there, right? So like the texture viewer, you can have these open sort of tabs, and you can open up a new tab and have a way to start something new or load something. Let's start there, and we can progress from there. Remove the line to match the Windows file, huh? What you mean? Hey, Mr. Test. Did I mess something up? Oh, I did, didn't I? Thank you, though. Appreciate it. I would have, that would have not compiled. Yeah. So, I think... So, the editor... I think we'll just live in the editor for a good while. So I don't know what I should do. So editor update, that's interesting. Right. It's all gizmo-y stuff. So maybe we should have a function called update gizmo, chuck it in there and get rid of this, because it's all kind of, it's just gizmo-y, right? All right. So let's go in the internals. And let's add, well, it's not going to the internals. Right, so we do something like static function called like editor update gizmo. Putting void be good enough. And we'll grab all that gizmo-y stuff. Let's chuck it in there. Right, this is like it. So we'll be like editor update gizmo. And chuck that all in here. Alright, does that still compile and run? Right, so gizmo value style. So this is a UI style. So I think what would be a good idea? Right, I see. Is we should probably have a section for all the different styles we're going to have for the editor. And that way we can... yeah, I think we could probably we could change it later, but I don't know. We could probably just live with the current style. Probably be good enough. Oh yeah, I'm testing out the gizmo, aren't I? Yeah, gizmo's still there. Cool, cool, cool. What? Now, the next thing we probably want to be able to do is draw the UI or something. So, UI, I guess, right? Edit a UI. Just call it here. So, if we go over to the GPU side of things, there is the tabbed area thing. So the way this works, because you might want to have, so my UI system doesn't retain, okay, it retains a very small amount of state. But I don't retain a lot of state per widget, so sometimes I have a little structure where there's some persistent state, and it's up to you to basically figure out how you want to store that. So typically, just make it static and put it inside the function. So it's got stuff like the selected tab index pointer, the tabs count, and the tabs capacity, and the sort of like, has something been added this frame? Have you clicked the new button? Have you clicked the remove button? So with this, you're given complete control of how you want to yeah, you even have to draw your tabs as well. So this means that we can pass in a different style for every tab, and we don't have to worry about how do we get the style in for the header tabs. Yeah, so it's a little bit of code you have to copy around, but there's not that many tabbed environments, to be honest, so ain't that bad. So UI tabbed area end. Just like that. Is that right? Tab area. Okay. So we're going to want to have some kind of global editor state somewhere. So in editor internal, we're going to want to have stuff to do with the tabs around here. So I believe we'll make a new thing called an editor tab. And a tab will contain information about what's in there and stuff like that, but we don't know what that is yet, so let's just put some placeholder variable in there. And let's take a look at GPU internal. What did we do for the tabs? Right, fixed set of tabs or with an array, select a tab index and a tabs count. Okay, so we'll just copy that, drop that in here like so, and we'll have a define, lovely little hash define for editor tabs capacity. So let's just say that at most is 8 tabs. That will be good enough, maybe. So editor tab, tabs, all right. So now we needed some kind of rectangle. So I guess we'll get the window rectangle. I think we'll roll with that. So we'll say UI rectangle, UI window rectangle. So we'll just be like, you know, it's full screen, whatever the size of the window is. And every frame this function gets called and we build the UI, it's just an immediate mode UI system, right? And the way that the system I went for layouts is, again, the UI system doesn't do much. It's very basic. We'll go to the implementation of it. It's 4,000 lines and it's got a bunch of stuff in here to do. It's got drawing in here. It's got tabs, layouts, combo boxes, popovers, scroll areas, sliders, input fields, radio buttons, images, a whole bunch of different buttons. But the thing it hasn't got is multi-line text editing. That's something that's still got to be added. But yeah, the whole point is you basically just, the user gets full control of how they cut up the rectangle and where they place the widget. But obviously there is clipping. So if you have a parent, you've got to make sure the child rectangle is within the clipped bounds, right? So yeah, it's quite powerful. So what we're gonna do, take a look at this. So we have this area, put in a rectangle. This is going to mutate the rectangle and shrink it down based on the margin, border, and padding. And then you can use the rectangle some more in here. So how does this one work? How does it get the rectangle? What magic did I pull off? Right. I retain it in some global, and then I keep cutting it left. All right, that makes sense. All right, so right, so you go over all of your. Right, so if we create a new tab, we need to initialize the tab. Right, editor tab init, we'll call it. Then editor tab remove. We'll get those added. Then we want to go over all of our editor tabs. Yeah. Then we want to go. So we're saying if we have something here, so we're going to have an idea of what that is. We display some different text. So what we're going to do is just get rid of that and come back to that and just say, put an index in there and just say it's empty. Or we can just say it's empty. What would be super nice though is if we had a way to have one with an icon. That would be pretty powerful. Maybe we can have a bit of fun, but today doing that. But yeah, for now, we'll just get this in. So tab in it. So when you initialize a new tab, what did the GPU system do for the right? All right, clearing at 0 is a pretty sensible approach. Tabs. Oh yeah, tab index. Cool. So a remove. What did the Oh, I did like a mem move, right? That actually has to do the remove. Yeah, I'm not sure how many of these we're gonna have, so this is probably alright. Remove. Nice. Wait a minute. What's going on there? Editor. Alright. Size of G editor tabs. Then whatever this is. So this is a editor tab. Alright. Looking good. So, shall we play around with our editor for now? So we boot it up. Wait. What is this constant? Alright. Looking good. Yeah. So if we give this a run every frame, it's going to run the editor UI and crash. So we didn't call the editor ends enough. Sorry, the widget end functions enough for some reason. I have no idea why though, because we are clearly doing that. What have I done? All right. So apparently it is inside this function. So I'm calling the end. That's for sure. Is this to do with these headers? Can I make that 0? So that is a thing, right? We probably don't have any tabs open, whereas in the texture viewer, we boot up the game and we go, hey, there's these 2 tabs for the screenshots, and it comes preloaded with them open. So perhaps I've not tested this code before with 0 tabs. So if we take out all these tabs, it still doesn't work. So the problem is probably to do with the fact that this code, right, here we go. What is this doing? Header visible. What is this? Interesting. Right, so this is about making a header. Ah, then it's going to say on the last header, do an end, isn't it? Yeah, when it's the last header, do an end. So basically, right, alright, so I'm going to run. But yeah, so effectively we have this, we have the screen, right? Then we've got these little, we've cut the top and we're drawing the tabs in here, yeah? So when we did a tabbed area start, we cut this box and started a new widget. And then we left the function, gave control to the user. And the user's got to go and put the tabs down. And then on the final tab, it's going to end the tabs widget. But because there's no tabs, it never ends the widget. So what we need to do is, be careful. There could be a bit of a hack, right? We could save a 0, do a widget end. It's really not the best, but I do not see us having that many tabbed. We should fix it some other way. It shouldn't require users being in. Well, the number of tabs is passed in, so the answer is pretty simple. You just say if state tabs count, right? If you have any tabs. Now, the thing is though, is you are going to, if you press the new button, you're going to up that, and that's okay, and then that will be displayed. Excellent. So, I should do it. No. What crap happened here? If you have any tabs. Alright, I guess we can put our breakpoint in now because I have no idea what's going on. Okay, so we do our tabbed area start, right? Opens up one widget. It's visible. We go through here. It does some maths and stuff. And then it, right, it has tabs apparently. Why does it have tabs? Ah, it's a pointer. Man, it's got... And also, these are pointing to the GPU ones still. Excellent copy-paste fail there. That's gonna crash still. Because the sick trap. I don't know. I broke the LSP. Alright. So in this tabbed area, we don't start a new widget if the dereference of that tabs count. Whoops. It should probably be named something better. But yeah. Right, so now we should get a tabbed area open, and this will be the humble beginnings of the editor, right? No. Has not been called 0. Ah, bit of broken English. All right, let's correct this. Right, so we set this sort of tab state thing, so you call it. Tabbed header has been called this many times. It needs to be called that'll do. So apparently in this tabbed area start thing, we set some tabbed state. Here it is. So we need to set that if there is actually any tabs that are open. Now, I think this, yeah, having that global destroys the possibility of some. Wait, no, it doesn't. No, I think it's okay. Right. I see absolutely nothing. We should be seeing the new tab. Tab header. Right, there's the new tab. Alright, maybe I want to change how this works. Maybe you always need to call it. I need to call it an extra time at the end. But if you did like a new tab, you could probably put the if statement around there and then you won't need to know. Yeah. Yeah, we could probably rework this a bit. So if you click it, why can't we return from the new tab header and you got the tab index in the for loop? Why does this need to be... Yeah, why does this need to be so... Yeah, we didn't need these booleans. Okay, this is interesting. Right, got me some ideas. So I think what we can do is we can rework this a bit. So you might not want to have tabs, a new tab button. And the way around that, so you can draw this and you want to say, so let's get some of these booleans, these boolean enum things that we got. Here we go. So visible, pressed, changed. So I did this so it's self-documenting, open. So I think we need a couple more. We want to say removed. Something like this. So there is a pressed, or I could just return the pressed thing, right? So if you press, oh no. If the new tab you want to do pressed, but yeah. Right. UI tab header. So for the tab header, it will return this sort of UI removed enum. And then you can have this UI pressed. And this can return the new button, we'll call it. It'll just be a little plus icon or something, no big deal there. So we'll make this, and you can always call it. So that'll be this sort of disabled scope thing. Alright. The thing is though, you gotta end the header, isn't it? Maybe we'll make that an explicit call. So disabled scope. Why did I want to do that? You're disabled if you've gone out of bounds on the tabs count. Where's the state? Must be called when tab start, tab end. We restore it back at the end. Right. If you press it, it sets the is new state. That's a big no-no. To be a pressed state, pressed equals UI not pressed. Yep. Cool. So I think that'll do it. I think we actually got to make a new one called like header end or something. Probably call it header area end, and that will finish up on the header area, because there's no way to automatically do it. You might not want the new button there. So I think it'll be a widget end, but with a check to make sure that you have actually instantiated all of the headers. So I think that's in widget start. There's a bit of a check in there. Right, so the tab state. So we could say that the next, if this is not equal to this, or the number of tabs, then we haven't called the header thing for every tab. Your header has been called, you know, X number of times. It needs to be called Y number of times. Right. Oh, sorry, to make sure it's equal to that. Damn asserts. Yeah. So that'll be sweet. Got the new tab button in a separate thing. This needs to tell you if it's been removed or not. So this here will right. Right, is this saying if it's the first tab, set this to just clamp it in between the bounds, just in case. Yeah, clamp it inside the bounds. I guess this could have been done elsewhere. Why does this have to be done in the when you call the header that many times? Instead, you could do it when you start the area. Wait a minute. Where does the tabs count get changed when you press the new button? Shoot, what do we used to do? So we used to up the count. Yeah, when it was new there. So when you press the new button, you can up the count. And I guess we'll clamp. Right, and then there's removed, and that could reduce the count. Right. So if you press the tab, so you could actually pass in the tab here, and then if it gets removed, nah, we'll let you do it manually. I was thinking you could probably get it to do the mem move for you, but you probably want to do some extra logic, so there's no point. Yeah. Okay, so right, so this selected tab to keep it bounded. Every single time you adjust the is it every time you adjust? Right, we should probably call this every time you start, just in case, because you could change it manually, I think. But also, we need to make sure that it's okay when we press this button and it's been pressed. See if it's been pressed. We want to up the tabs count. State by 1. And the selected tab will now, will be the right. So the selected tab, okay. But you only really want to allow this if, it doesn't go above the capacity. It will be disabled. That's good. Nice. So let's deal with the removes logic. So when you render or do the header, the tab header, it can return a removed. So you do the toggle button. If it's visible, if it's the selected one, we can display a little delete button basically. So we'll do this removed thing. Yeah. And this will just set removed to removed. And then return removed. Now, what we'll do in this, so it would used to set the selected, let's go to the UI header for a sec. It used to set, means selected tab must be shift removed, right? So it used to shift remove the selected tab, but then, So you press the remove. Yeah, you're only removing the selected one anyway, aren't you? That's correct. So yeah, then you can go state tabs count minus equal 1. I got to do the deref. No. Yeah. And the selected tab index will be clamped the next time around. Right. That will work. So I'm wondering though, when you say it's removed, you would have successfully drawn this. Yeah, we'll see how this goes. Right, button end. Right, I think that's okay. What is this? Been pressed. Right, we're okay. So I guess let's play around with this adjustment that we've made to the UI. Onto the tabbed area code. Should be alright. So you need to make sure you call this though. This is a very big problem. Now, there's no way to know whether you've called this sort of header tab. Yeah, we just put the new widget here, which sucked. Unless we put it all into one. Yeah, maybe we should. Maybe it can be in a few different states. Or maybe when you do the new button, it just ends it. Yeah, that's what we'll do. Alright, I think we've sussed it now. Okay. Right. So you can only call up to new button. There we go. So let's go to the editor and we'll comment out. I guess we'll refactor this code and then we'll do it to the, then we'll comment it out and do it to the texture viewer and we'll test out the texture viewer. So what's changed now is you can tell if this one has been removed, right? So we can say it's better off if we probably put it into a local, keeps it readable that way. And then we just say if removed, then we can run that remove, right, on this current tab, right? Oh, pretty sweet. Then we want to be able to say if UI tab new button, right, we're passing the style for it. We can then initialize the selected tab like that. Right. Cool. So let's go over to the GPU side of things, or let me quickly comment out the editor UI just for a second. So let's go to the tab area. So no longer is there this is new state or whatever. Doesn't exist anymore. Instead, we do the removed if removed like that, and then we've got a new button. If UI tab new button, UI box style or style box. All right, give that a go. So let's give that a run. And press F9, and we're presented with an assert. Right, so called new button. Yeah, it got in a bit of a weird state, that's fine. So, I know the problem. We got rid of, yeah, did this already, it's the problem. Got excited. So, it used to say on the final tab, put the new button down, but I've taken it out of here now. So we restore that tab state thing. Global. Then in the new button, it will make sure you still that tab state thing. I should put a comment here. And the header widget. The header area widget. Right, that's what that one does. Right, and this ensures that we ended all of the... And that ensures that we ended all of the... or we rendered all the tabs. Cool. Right, so let's press F9 and take a look. No? Alright. Right, so we've still got these tabs. They seem to click OK. Click the new one. Doesn't like it. 1524, eh? So press the button. It's definitely... I didn't dereference it, so I just increased the pointer. There we go. So we can open up a new tab still. Close doesn't work. It needs to be called 2 times. Right, so this is where it's actually going to mutate it while it's running. So I guess we can hack around that by removing the... by decrementing that state. It's called... Tab next index, take away 1 as well when we remove it. It should hopefully do it. It might look weird for 1 frame, but it's so quick it doesn't matter. Right, there you go. Right, so if you remove one which is not the end, it's a bit of a problem. Has been called 1 times. Right, so we'd have done the mem move, deducted it, and then the for loop wouldn't have... Yeah, so there's a for loop. So you're looping over tabs count, and that gets mutated. So actually, it doesn't end up running. Alright, what would it solve this problem? So you could have an index that you just store, and it will tell you which index has been removed, and then you can say if there has been something removed. Well, you're just looking for the current one. So I guess you just do this. It's a bit of a weird way to program it though, not gonna lie. Does this escape the problem though? No, because it doesn't escape the problem because the count is still adjusted. Yeah, this is the problem, adjusting it while it's still going. So I guess in this case, you'll just deduct the index. You'll just go index minus equal 1. It's a bit dodgy, but there's not going to be that many tabbed UIs. We can always improve it later. Right, that closed. And you can close one from the end. There you go. Oh, can close one from the start though. Yeah. Hmm. Right, I wonder. You could probably use a goto or a signed in loop. Hmm. Yeah, you could probably use a goto or a signed in loop. That's dodgy. Well, what's the problem with it not doing the correct number of tabs for a single frame? Let's try and get it not to assert. I guess is the problem. So why does that assert again? I can remove that one. Can't remove one that's not the end. Right, because it changes the number of tabs. Right, we need to change the index, isn't it? Yeah, I guess if we can change the number of tabs, in new button, something like that. That will solve it. Yeah. All right, I got an idea. So new button. Yeah, so in header, we don't actually change the number of tabs. We just say it's been removed. But then you want to mark in then if you the new button, we just say we can then just take the state and drop the count by 1. Then obviously restore that back to 0. Yeah, so that'll be true. So I think that will solve the problem. Didn't dereference the pointer again. Cool. Yeah, then you want to clamp selected count. Right. Okay, so we add a new one. We remove the end, yes. We can remove the middle, yes. And we can remove the start, yes. Cool. Right, there's the tabbed area working again. You know, I'm not sure if that change is actually better. But yeah, I guess it's just another way of doing it. There's now less state in this sort of tabbed thing. And the new button is independent. Yeah, we had that problem where you had to at least have a single tab, but now this has solved it. Where you don't need at least one tab because it wasn't ending properly, the header area. So that's cool. So it solved that problem at least. So now we can re-enable the editor UI and we can have a bit of a play around with that. So it's just some tabbed UI. Okay, so there's nothing being rendered. But we can click a new tab, click a new one, and we can close them. Sweet. Okay, so next thing to do is to fill in some areas. This is the texture viewer. It had like a split area if it was open or something like this. So I think what we need to do is think a bit more about how we want our editor data to look like. So we're going to be having essentially three different editors: a level editor, a model editor, and a material editor. We probably want to stick we've just got one internal header and one public header for all of them. So I think we'll just stick them all in here like this, into sections. And like a model editor here. So right, we'll probably have like a common area which just reflect, you know, there's common stuff between all three. So we're going to need a material editor and an actual material that's being edited, probably. And then the tab has got to hold probably a union between a bunch of things. So I guess I'll call that a material editor. Right, makes sense. It's obviously not keeping to the standard of saying editor than this. But it reads better. And if I had something called editor material, then, you know, yeah, it just sounds like an object. Or it'll be called the editor material editor. So yeah, naming is a thing. So we probably want to obviously have like some kind of open item that's being edited right now. So I reckon this will hold all of the state. You know, it will say like, it'll hold the memory for all the materials, which we haven't got yet. So I need to make this structure. It'll probably come from the encoder system. So we'll probably have an encoder system for materials. And that will be code gen serialization. Then we need a way to say, hey, we've got this material open, and then some kind of it has some reference data to the material editor or something. Now, let's say which one it is editing. So potentially that's just going to live in the tab. So we want to be able to have a material editor. Now, what do we call it? We can call it like an item. It's an item that we're editing. Probably not a good name. You've got like a model. So you can have levels, models, and materials. We need to find some generic name. Like the word file makes it seem like something that goes on the file system. Probably not a good idea. You want some generic name, but it's got to be something that just makes sense. I could call it material tab, right? And then it just you know, it will go into the editor tab. It'll be unioned or something. Editor tab, material, something like that will probably be good enough. So in here we'll have probably like a material index, maybe not an index, because you could insert new things while it's open. But yeah, something, or remove stuff, right? But yeah, maybe you would have some. But we need to have some way of referring to the actual material. So, well, so every time we'll probably have an array of these materials. You're going to want to have probably the string identifier of the actual material. So I guess that's going to be a fixed size. Yeah, this really needs to just all come from the encoder system. So I guess why don't we just dig a little bit deeper in a second. Let's just get this, finish this thought. And I think we'll use the encoder system, code gen a file, design the data structure that we want to store the materials and get the serialization in there. We can just get going on this a bit more. So the material tab is probably going to have like it's going to be like a tagged union, right? So you say editor tab type. So you have a level, or you have a none, I guess. You have a level, you have a model, and you have a material. And we'll also probably have a count that just, tells us how many of those enums that we have. Then we uppercase all of this, like that. Then we have a tab type that goes in the tab. And then we have a lovely union which will house the editor tab material. So essentially whenever we instantiate a new tab, we'll give it a tab type, we'll give it a tab type of none. None will mean we've got to try and figure out what this tab is, and it either loads the file or it makes a new one. And then whenever it's figured it out, it will instantiate the data with the correct stuff there. So it's looking good. So I guess let's use the encoder system. Be quite fun. We haven't used that yet on stream. I've just been testing it off stream. So the encoder system we wrote probably 8 streams ago now, or more, probably 10 streams ago. And then off stream I've been finishing it off because there was lots of like final touches to do. But I've added things like string support and tons of things. It's still got to be finished off in some aspects, but it's ready to be used for the material editor. So yeah, I think it works, but I think I'm halfway through doing another feature and I think I've slightly broke it, but I can always easily fix it. So the way the encoder system works is you make these files. So in the editor we'll make a file and we're going to call it we'll call it material.enc. So now I don't think this should go in. So this is not really an editor thing, right? So actually, let's get rid of that for a sec. Where's it going to go? So it belongs to the game, and the game loads these material objects, and then they will get passed to the renderer somehow. So I think it belongs in here. This is the test one that I've been using. So we open up material.enc and we've got to put it at the top. We've got to say, I've already forgotten this. We need these things. So we want to say, what is the target for this encoding thing? We're targeting a file. We want to support text and binary. So when you support text and binary, it means that the even versions will be text files and the odd versions will be binary files. And the idea is the text files have relaxed rules, which allows you to change how the data is structured. And then when you want to release, you can up the version and solidify that and yeah, you can make a binary file. And then whenever you're going to do a new version in the future, say if you want to do another release or change it some more in the future, you up the version again, and you can do an upgrade from previous versions and stuff like that. So let's do the fun thing and make a magic number. So, hey, Kept Payne, how you doing? Off topic, but what the hell? Thermodynamic computing uses the noise that... Huh? Never heard of this. Thermodynamic. They rely on binary logic, electrical circuits. Thermodynamic computing leverages natural tendency of physical systems to minimize energy and reach equilibrium states for computing. I don't know, never heard of it. Oh, of course, the first thing is, and how does it help AI? But yeah, never heard about it. Right, ASCII to binary. So the magic number will do a... So... Should we do mate? Sounds pretty English, doesn't it? Or my hex. That's what I meant. I could have obviously looked at the ASCII, right? So I think I don't know what way around I want to do it. It's man me ASCIIs. So capital M is screw you. Capital M is 4D. So it does come first. You see, I wonder, right? Should we do like big endian or little endian order? That's always the question. So yeah, the magic number for the file is going to be mate. So should I inverse these? What should I do? So little endian comes first. So we're going to see it as mate when we open up in a file. It needs to be the other way around. Right, so and we can test this out. But yeah, 4 5 5 4 4 1 4D. So M is at the back, then the A, then the T, and the E, right? So now we can actually do some data structures. So from here it's basically C, but it's got some extra bells and whistles. One, you can't type def. So you kind of write like C++ where you just write the strut. And it's got some extra types like packed types and things and support for variable length arrays. So we're going to have a thing called a material. And the material is probably going to have some name. And we also support constants, but they have to be const expression because it can't be bothered to support preprocessor. So I thought since this was C23, we might as well support const expression in this thing. Then, so How big do I want this name to be? I don't know. But yeah, we want some form of like albedo color. And sRGB is good enough. So albedo. What other things did I have? I have I could probably use my packs types from here. Although I don't know. We probably do full on floats. But I think there's like an emissive color as well. Emissive strength we need a metallic, so metalness. Yeah, I'm not really too fussed on these new computing technologies until they become a reality, really. You know, you hear about quantum computing for years. I don't know when's that going to be usable for like everyday people, really. That's what I'm interested in. So yeah, unless it replaces classical computers, I'm just gonna stay doing classical computer stuff, you know. Yeah, if it interests you, maybe see if you can get into the field or something, you know. And then the other one is roughness. So I have a very basic PBR setup. I don't have any of the extra bells and whistles. We're still doing other parts on materials, to be fair. So what types should these be? These are typically floating point. You know, technically metalness should just be 0 or 1 if it's going to be correct. But float, you know, it's a game, so you can kind of do what you want. Roughness is 0 to 1. And and then yeah, so the strength. Did I have? Let's go to GPU shared. Graphics. Yeah, so we've got a packed material. We didn't have emissive strength. Why don't we? Right, because is it combined? What's going on? I didn't really do emissive properly. But you need to have an emissive strength. So you take your color and then you multiply it by something. So I don't know what that would be. Maybe we just make it a float for now. We can always optimize this later, right? Yeah, you change it from a float to a packed float. Let's make it a packed float because we can change the min-max values with that up in the version. So I've got these things called packed types. We can specify the number of bits they're going to use. So I don't know if I really need to pack this down super, but it means you can specify min and max value, which is useful in and of itself. So we could probably keep it 32 for now and always change that. Give it all the precision we need. But yeah, we could say emissive strength is from 0 to you know, we could say 1024. Bit much, probably a bit too much, but let's just say that. Metalness, let's give you another. We probably need you to be B8s because that's how it's gonna get packed down anyway. So maybe we can say so we'll say 0 to 1 inclusively, right? And then another B8 for roughness. That's how it's going to get packed on GPU anyway. So that'll be a different file. This is one that we're storing for the editor, hence why it's got a name. So I think we could probably get away and make that a B16. So it's using 16 bits, and that way that'll add up to 32, meaning that'll be 3 32s there, should be quite right. So in terms of like a name size, so it will just start typing random stuff, and the number in the lower right hand side, which my face is covering, I think. No, it's not. The number down here says 632, line 632. So this is how long the material name could end up being. And I think that will fit. That will fit everything we could want, right? You know, you can call it wood. You can call it super omega awesome wood, right? And you still have enough room. So I think that'll be good enough. So it's a null terminated string, by the way. So yeah, I guess let's see what happens when we run the encoder system. Bearing in mind, I think I've got to edit the actual encoder gen because I don't even have a way to Right, let's do parse and gen logic material. So I don't have a way to let parse in a file right now, and you can just do multiple of them. So I might get it. You know, I've got to figure this stuff out. What do I want to do? So I guess this is another thing on the list. How do we add new files? But yeah, so let's launch it, see what happens. Hopefully the computer doesn't blow up. So we run the encoder gen. This compiles the script and then runs it. Right. Yeah. Let me disable the test one. Come back to that when I work more on it. Hopefully it still works. Invalid suffix 217. Material encoder. Right, something's up with my parsing. What's going on here? So when you parse the magic, why do the other magics work? Oh. Right. Maybe because it wasn't doing hexadecimal. Right. Alright, let's correct that quick. So I've got a function called parse num. Clearly it's not parsing the numbers properly, but it's done in a very silly way. We basically just like scan. Yeah, we scan the string until we reach something which is not a number. And we figure out like if we found a dot, it's a float, right? Then if it's got a negative symbol, pass it as a signed number. And we'll just use the standard C stuff. I could have done a proper one, but I couldn't be bothered to get it right. Correct. I've done one in the past, right, in my other C compiler, but this was just easier just to do. So I think the problem is that we simply just it's checking a character, then it's like, oh, this must be a float, but it's not taking into account the radix, right? 0x would have been picked up, radix is 16, so this doesn't apply. If radix is not 16 and f, U and L and all that still applies, so you can do that. So let's try this out. Right, how does it set an invalid? So is alpha, right. So again, you say if radix. So you want to say else if radix equals 16 and char do I do anything to do with A's and... Right, let's make a function for it. Is hex digit. All right, so in that function parse num, we'll just go, well, if it's a hex digit. Well, maybe we don't let it get here. What's going on? Or radix equals 16 and is hex digit. Something like that. And we can get rid of that line and get rid of that suffix checker. But you still have suffix stuff, so yeah, I guess we'll do this. Yeah, commercialize able things, I agree. Oh no, it interests me, but that's a lot of work and thinking. Right, okay, you're being an enthusiast. That's cool. Right, let's run that. Cool. So what's this component? I got D. What? Right, it would have said found suffix, bugger. Found suffix false. Awesome. So now let's go back to the material. Something else is buggered up. Must be in decimal. What? When does radix equal 16? Huh? Did I start off with a 0? Okay, I started off with a 0 and it made it octal when it... Oh man, C parsing. Ugh. C parsing. Horrible. See, if we come across a dot... If radix equal to 16, error, radix equal 10. Oh, right. Expected root to be on the root structure type since it is a file target. Radio. So yeah, since there's a file target mode, let's go to the material encoder. We need to mark this thing as the root object. Wait, do we? No, that is wrong. We've just added a material. What we would like to have is actually the material file. And it's going to contain all of the materials in here. So this is where we get to use the variable length arrays. So we'll be able to say materials count, and then say material, materials, and materials count, like this. And it will simply just, you know, have a variable length array. This will technically be a relative offset. It replaces this with a U32, which will point further along in the file, and this is essentially stored after the file in memory. Yeah, it's just bump allocated on the end. And you can have variable length arrays inside variable length arrays, and it just keeps bumping it on the end. So yeah, now I'm thinking, do we want to have some sort of like naming scheme? Well, we don't really have to care about some naming scheme because all file encoded stuff starts with a version number. So it'd be like V0 will be the first one because it's all versioned. So we don't really have to care about a naming scheme. You would know that it's a file encoded thing. So if we run this now, it should work. Oh, I didn't put root on it. This is our root object. We don't have to worry about a header. There's implicitly a header placed on, which is the encoder header. It has like the version number, the name, data types hash, and stuff like that. So now we've got our lovely generated stuff. So we've got this file. So we've got the encoder file, we've got the database file. So the database file is basically an explicit version. So it contains all the versions, and it contains the types. So it means that when we make a change, it will validate if the change is allowed. So since it's a text file, it's got relaxed rules, we can add new fields. We can mark stuff as being removed, but we can't actually remove stuff. So if I was to delete roughness, it would be like, hey, you've deleted roughness. So if you want to do that, you've got to do an upgrade. But we can also mark it as being removed, and that will, in the code generation, it will put the fact that it's been removed. It will like change the name to like underscore removed. So you can sort of mark stuff as being removed, and then when you up the version, it won't allow you to complete the version upgrade until you've removed all your removed stuff. Yeah, so we can't change the data types either. They're fixed now, but you can change all the bit-packed stuff while it's a text file, because if it's a text file, it doesn't care about stuff being bit-packed. So that can all change. So yeah, why don't we take a look at the code gen? So it's made this generated.h, and it's got the constant expressions, v0 material cap, that comes from the here obviously. It's got the material, it's got the, it's just a fixed array of name, albedo, emissive, and then bit field 0 where they're all packed. So you can extract the emissive strength like this, and it's code gen everything. And if you have bit fields that go over word boundaries and that require 2 words, it correctly works out that extraction code too. And yeah, this is the set code. So essentially like works out to scale things and offset basically. Yeah, so what's going on there? You've got a full on 16 bits. Yes, that's the, yeah, okay, that'll work. Yeah, so ways to basically load and store into the bit fields. And then we've got the actual file. Here's the header that I was talking about. It's got the magic number, the encoder version. So if we ever change how the encoder system works, we can handle that. It'll be a bit hacky probably, but we can handle it. The file version 0 right now. The size of the header, just in case this header gets changes, we need a new header. The hash of the data types, just in case you do branches and change things on 2 different branches, we can catch that. The size of the whole file and the checksum. So it's just pretty standard stuff really, with some extra things. And then there's the materials. There's the byte offset that I mentioned, since it's a variable length array. Right, variable length array. And essentially we have ways of getting that. So if the variable length byte offset is 0, if it's non-zero, so as in it's not pointing to itself, we can offset from the address of the byte offset and get the array, the material array. If not, return not. Then this is for when we create these binary files. We can use the binary writer and get it to create the variable length array for us. Yes, the way the encoder system works is that you always make the binary file when you're encoding, and then you give it to the text serializer, and then it will go over. So we've got some stuff here, right? This is all the functions. So you'll do the CSON encode. It will take in the material file object, along with some other things like the asset path, where to save it, and the like a custom allocator and an error message, just in case it fails. And then we so you always build the binary file and you just send it out through the text encoder. So this is CSON, it's just a custom C JSON thing. And then we've got this sort of, and the decoder will always write you out a binary file, basically. So it's all in memory. The binary file just gets mem copied. If you see the implementation of the binary encode, it doesn't really encode anything. It literally just mem copies it. Literally just writes out the whole file to disk. So it just verifies to make sure all the stuff makes sense in the header file and the checksum, I guess. Make sure you've written out correctly, and then it will fire out to the disk. So the text one is a little bit more hands-on. Why is there no upgrade? We have no upgrades, that's why. And there is. Shoot. Why does it think the material needs an upgrade? We got ourselves an error. Right, I messed up the code gen here. Let me correct that. Hey, Siyasha? Siyash, that's it. Hey, I'm not doing bad, thank you. I'm doing quite good. How about you? How you doing? So that was the binary upgrade. Huh. Why is that root type so wrong? Oh. Latest version root type. So I didn't set the context aware printing correctly, so it used the previous one that was there. Right, let's rerun it. Awesome. Material file, that's good. So that looks alright. Right, so there's no compile errors. So yeah, all this CSON stuff is doing is we've just code generated ways to read a CSON file. So you'll see the CSON file in a bit. Maybe in next stream, but let's just get using this thing now. So since we've got the code gen stuff, and get back to the editor. and go full ham. So in the material, we can actually put materials in here. So let's have a material file. V0 material file. So here is the material file. Do we want the whole file there? Probably not. We will probably extract all the materials and then allow you to edit them or something like this. We need to know if the material has been opened or not. Maybe we can have a runtime type, which is probably quite similar to the we might just unpack it all. So just use the, there's no point packing stuff down at this point here. So we'll probably just have an unpacked version in the editor. When I don't understand what's going on, I just follow. I just took a never-ending task making a 2D card game. Cool, awesome. The main thing is I'm making it in TypeScript. Okay. It's alright, I guess. I guess that's what you're most familiar with. Alright, so I have this material. The reason why I do it like this is so we can actually add more things to it. Although, if we just took a mem copy, we could have, like, I want to know if it's been opened or not, and then if it's been changed. If it's currently open, if it's been changed. If it's already opened by some other tab. And we also want to know if it's been changed. A good idea. So if the material has been changed, it needs I was thinking for these materials, what you could do is you could store the entire, for a lot of these files, you can just store the entire history, and then you run over the history, and that's your latest file. And then it means when you load it up in an editor, you have the full undo history for the previous file, like what it took to make your thing. So maybe we could do something like that instead, where we just have the entire history of the edits. And then you can look over all the edits and be like, and see what people have changed in regards to the file. You can be like, what was that before? Oh, it was this color, right? And that'd be quite powerful. And you can have a date on it. You can say who changed it as well if you really wanted to. And then when you load it up, you'll have a list of history that you can then just change with the latest results. But then I guess that would be the sort of editor version of your asset, and then you need probably when you release the game, you probably want to take that and compile it down into the file we've just made, right? That makes the most sense. I see guys like you code, and I see myself code. It's like I see a scientist. Oh man, don't feel that way about yourself. When I was, I don't know, about 15 years ago, I started programming in JavaScript, and I think I was doing it for like a couple of years. Maybe it was 16 years ago. I was in it for a couple of years, and I remember thinking to myself, like, I tried to learn C and C++, and I was looking at, I really struggled with like pointers. Some are very basic. And yeah, I said to myself that I would never learn. I'd never learn it. It's just too complicated for me, right? Things like that always feel that way, but 2 weeks later, I got probably a little bit depressed. I didn't know how to make an executable file, and I tried again, and I must have found another resource, and I just was like, oh, okay, I understand it now. And it's just a load of that, basically. You just get just challenges, looking around. But if you ever want to come down into the low level side of things and want to help, we do have a Discord channel. Feel free to ask questions. Got plenty of people in there that can help out. But yeah, I do. I find the low level stuff a lot more pleasant to program in, and especially when you make all your own technology, you get to make your own decisions for a lot of things, and it's quite powerful. But even if you want to there's plenty of good stuff out there to use to make a 2D game that you could probably get on with quite well, to be honest, and build some stuff for your game. But yeah. See, I'm thinking, so what did Past Henry do? Past Henry came up with a game tech plan, and did I say edits? Let's look for the word edit. Yeah, so for the model editor, I was like, we should just store all of the edits, and then we will keep the undo and redo between sessions. That'll be pretty cool, wouldn't it? And you can see the history. And maybe even in the future, if we get multiple people working on the project and it really matters, you could probably do some intelligent merging thing, right? Not that it will matter that much now, but it might do in the future, right? So I think maybe, right, we should have the sort of release material file. Like, this is the one that we ship with, and that's the one we just made. But we should also have the editor one. So let me take this encode file, and in the editor we'll do an editor material.enc. All right. Now I've got to be careful. Oh yeah, it's going to generate an underscore yeah, the file name will be different when it's generated. That's cool. So I think, right, we should be able to go to an editor material. Now this time, I guess we'll call it, so this will only be in text format. So we don't need a magic number. And so the other one is probably only going to be in a binary format, since it's only going to be for releases. Yeah, that makes sense. So I think we'll have some other system that will sort of pack it down into that release file. So we might have to delete that database file, but yeah, it'd be binary only. I think that'd be cool. So, right, logic, let's delete the database and delete the generated stuff. We'll regenerate it since I've just broken compatibility. but it doesn't matter since we haven't really used it anywhere. So in the editor material, this is purely a text file. We'll call it editor material. I've got to be careful. So we don't really have a material. This is the thing, right? We have a material, editor material. Do you want to call it an action? And the idea is that you change. So we have enum support as well. So you say editor material action type, I guess we want to call it. So it's going to be a bit long, but oh well. And the idea with this one. So this will be versions as well, v0, v whatever. So the action type will say, hey, we've set albedo. Well, there's no such thing as really set. We'll just call it name, or maybe we'll call it property. Have a bunch of properties, or prop type. Bit shorter. So the idea is you have like a name that you can change. You have albedo. You have the emissive color, emissive strength, and then the metalness and the roughness. So I guess we'll have a count as well, maybe. So the idea with this property do I call it prop type, the type of property, or do I call it a prop? Yeah, let's make it a bit shorter. So I think when we have an action, it changes a property and it changes it and gives it a given value. So I have support for unions as well. And since it's a text file, it's going to need to be a tagged union. So we're going to have to do some things like editor material prop value, we'll call it. So I've got to say tag editor material prop. So this is because it's a text file. You have to do this. If this wasn't a text file, you will you don't have to have this. So then we can put in the different types. So we need a char name, material name. So can you change the name? That's the question, right? Let's say you can't change the name. If you can change the name, I think the thing's not that important. Well, you might want to change the name. There's some questions with. All right, let's. So if you change the name, like say if you did some merging in the future and you've sort of changed the name twice, whatever, for some reason. So the name actually matters, right? It's a way of identifying the material. So when you say I've got this sort of like wood material and I've made a model out of wood, it is the identifier of the yeah, maybe you do want to rename it though. Then if it's missing, yeah, okay, I think it's okay. Let's just say you can change it. So I guess you got to say key, editor material, prop name. So we just got to do a bunch of stuff like this. E32, we'll call it albedo. You know, we can't just call it color, unfortunately. We've got to. I haven't really added support for doing multiple keys on the same field type. That would be an interesting thing, though, you know. But then it will get quite long. Albedo. Emissive color, emissive strength, metalness, and roughness. Alright. So we'll do the same thing again. Luckily we have cursor. So I could probably do something like this. Alright. So if we have this, then it means we can build an action will just be so you have a property and you have a value based on a tag. Now you need the tag field, right? So you need to say that the tag field is prop. So yeah, again, we don't need that for if the file was in binary, because if it was in binary, you'd literally just memcopy the data to disk. This one needs to know so it could evaluate the text. And I think storing it as text would be nicer because you can see the file and merge it. So I think for editor stuff, we're going to keep it all in text, and shipping, keep it all in binary. All right, so when you have so we haven't really got material, editor material at this point. So the material is just going to be the whole history, and there'll be some variable length array. So you just say actions count, and you'll drop that in and just say actions count. Something like that, yeah. And then when we load into the game, we'll just run over all the actions and then compile a final material. This is only in the editor. We'll do this. So we'll have an editor material file. So this will test out multiple variable length arrays. So you have your materials and then editor material. Okay. So I think that would be a pretty cool way of structuring the editor, is that if everything was done like this, it'd be pretty powerful. So let's run it again. Oh, this time though I've got to edit the encoder gen because I've not finished it yet. Let's add another file, editor material. So that will then read the editor material .enc file and do it all proper. Right, so the target should not have the same target specified more than once. Right, I've seemed to have not reset some state somewhere. Right, it's pretty dangerous. So I think in the generator, right, we zeroed the generator. It might just do it. Right, the magic directive to follow the file. We need magic? Oh, apparently we need magic for a file. Okay. What is a magic number? For a text file. Oh, well, let's make one up. Where's the, yeah, we'll just, well, the same magic number even though it's only a text file. That's the point though. Oh no, the magic is put in the text file as well. We can see that in the future. Alright, what is this? Cannot find constant expression. Alright. So the issue is we're going to have this sort of material name capacity. We've got two different ones, and so they can go out of sync. Can be problematic, but the design of this encoder system is that we don't support including anything because everything should be self-contained. Because otherwise you start running into problems with versioning of things. So we'll see how this goes. I'm hoping we don't have to care about it too much. Right, so it seems to have ran. So let's take a look at that new editor material generated. H. So yeah, we've got the capacity. We've got a lovely enum. It's explicitly done. This property could actually be made a U8 though. But this will be aligned to U32, so it doesn't really matter. Yeah, this all looks all right. So here's our variable length array stuff. And then the file as well. Cool. So I guess we can get using it now. So in the editor, internal, so I think we'll have the whole history. So I did this sort of like core define stack. So this is like a growable array. We'll do a v0 material editor material file. Now I don't really have this included. So I include the material editor material generate.h. We'll include the C file in some other place in a bit, but that'll at least get those things going. Nice. Material editor material. Now we only really care about the actions. So if we have that core stack of v0 editor material actions, this means now we can view this history whenever we open an editor with this material, and also then actually mutate it, potentially. Well, yeah, let's leave it there. So, right. What's next? So you have this is changed. Well, you have like an is. So we kind of want to know if the material is already open in some editor, and if it's already open in some editor, we need to be careful about it. You know, not to open two of the same materials, that'd be quite bad. Yeah, maybe you would have a tab reference to say like, hey, this is the well, not really a pointer, but like a tab. Well, you can't really do it. One. Maybe we'll have a name hash. And the name hash we can use to figure out if it's open or not already. So this is all the evaluated data. So we'll take all those actions when we open it up and just we'll clear these to 0, run over all the actions, and that will set everything up with the latest version of that material. So the editor is going to have in it, should we have a pool of materials? Then you have a pool of materials. You can always create you can always allocate and deallocate some, or you can just have an array of materials, which you would then basically shift and swap remove materials around. Probably shift removes it to keep it in the same order, but yeah, if we did an object pool, it would then mean you would get an ID, and the ID would be fixed and it won't change. So that'd be pretty nice. Because this tab, how can that reference a material? Does it be like, it probably would be like, hey, this is my name hash, and then I've just got a local copy of the whole material in here. But then you'll be but yeah, then you would say tab material. Oh well, that's life. So you would take a deep copy of that, so you can edit your own stack, and then you can save it and put it back. Right, that's interesting. Yeah. So if you saw the name hash, you'll be able to fish it out from here, so you can do like a core stack. We'll have an array of these materials. I should probably call them editor material, not gonna lie. And then we also need to type def this thing. Alright. So that's me a v0 editor material name capacity, something like that. Oh shoot, I did not change that name. And the name prop crap. Editor material encoder. Or I didn't change it here. Alright, so rerun the code again, it seemed to have worked. Okay. So back to the editor. Yeah, so it's quite powerful. We can now have an array of materials. We can push and pop these things. It doesn't matter. We're not holding direct references to them. We probably won't store the file in there, but just have the materials as some array. Yeah, so I think this is how the editor is going to mostly look. Like, how do we know if we got saved changes? Well, you basically say you have another integer in here, and you just say, where was the last saved action count? Right, so if you undo, no, you got to be careful. Do we need some hashes? So should each action have a hash of the action of everything that comes before? But then if you did that, it might be problematic with merging in the future. You'd need to have a merge tool that done it rather than people hand doing it. Yeah, I'm wondering how we can keep track of if the file needs saving, basically. Well, you probably just say, maybe just a boolean. Hey, it's been changed. So you might have like an actual sort of like action cursor. So the cursor will always be at the end. When you remove stuff, it brings the cursor back. When you write new stuff, it will remove everything from the end. And then you actually yeah. Yeah, that would make sense, wouldn't it? It's how an undo stack behaves. Yeah, it'd be something like this. But I think we'll solve that problem later when we actually need to solve it. Right. So yeah, the tabs have a material and their tag type is material, then we'll end up using that. Cool. And all the open tabs, nice. Right, so I guess what's the next thing to do? So the next thing would be we need to be able to create a new material in the UI and open up the material properties and have them displayed on the side. And then on the right hand side, we can display a render of a sphere of a sphere with the material on it. And you could probably give it a rotate or something, I don't know. Probably change some other things about the environment as well. But yeah, I think that's a good start for today. So we'll carry on Sunday. So 4 hours ago on Sunday, we'll be doing. Yeah, we'll make that property panel on the side and put a sphere in the middle that we can then change the material of, and get it saving out to a CSON file and loading it back in. So I think that's the objective for probably Sunday, and then next Tuesday's stream, which is about 2.5 hours ago, but on Tuesday and Thursday next week. But yeah. Right, I'll check this code in tonight for those of you who have access to the code and supporting the channel. Yeah, thank you for everyone who's supporting the stream. Appreciate you guys. If you'd like to support the stream, you can follow the link there and get access to the code as well. But yeah, there's also a VOD channel if you want to get up to date on some of the past work that we've done. It's accessible there. There is a main YouTube channel, but I keep getting, you know, too busy to do YouTube. So just VOD channel is for now. But I'm hoping to do one for the encoder stuff. Alright guys. Appreciate you all coming. I hope you have a good start to your work week. Sorry, your weekend. And I'll see you. Oh, I'm so tired. And I'll see you all on Sunday, hopefully. Yeah, much love, guys. Catch you later.